All right, good morning. Welcome back. Happy Monday. Yeah, glad you made it. We're starting into week 4 of this digital online virtual thing. Yeah, and you're doing the things. This is a 9-week quarter, so technically somewhere in this week is about halfway. So that hopefully maybe some solace. That's wrong. Sorry, halfway through next week. That was some mental math right there. Yeah, let's do it. Your quizzes look nice. Those are going to go in the gradebook while you are watching this, right now. Here we go. We're starting into something new. It's a Monday. It's new time. Okay, so today's new thing is called this. And sometimes I start this off by, presenting that on the board and being like, hey, how do you say that? And everybody makes some guesses and you get some stuff going on. And can't do that here, but, stoichiometry. Stoichiometry. I once put in random recognition for something about stoichiometry and had to teach Mr. Leaf how to say stoichiometry. Because it's a weird looking word, right? Like, this is not intuitive. Stoichiometry is kind of the science, the measurement of how much. So, like, how much element you're using. And sometimes we start it over here. If you have the packet, you're looking at this one. If you don't have the packet, no worries. This is really not the most complex thing I've ever printed. But we do, okay, so it's the measurement of amount of chemical amounts. So measurement, I was trying to show you here is that it's like a recipe. We're gonna write stoichiometry on one side of this table and a cooking recipe on the other side of this table. And that, to me, that's kind of one of the best ways to think about what it is, because it really is a recipe. Like, in a recipe, you've got a cup of sugar and a cup of flour and 2 eggs and some milk and measurements, right? Like, if there's no measurements, then your result is going to turn out really funky. So stoichiometry is exactly like the recipe in that we're not just saying mix together some salt and some flour and make a cake. We're saying this much salt, this much flour, this much sugar. That's the measurement point. That metry is measurement. So the 2 cups is the measurement of the, and then stoichio just means element, thing on the periodic table. So element, measurement. Instead of food measurements when we do, let's just do it, stoichiometry and recipe. I was going to put this on my page so that those of you with no packet can have it the same way also. Let's do it. Okay, so stoichiometry is the measurement of elements. There we go. Stoichiometry is the measurement of elements. And we can think of it like a cooking recipe. And specifically, that cooking recipe is telling you how much of what. Those are your kind of 2 key ingredients, key ideas here. 2 cups of flour instead of 2 cups of baking soda. And both things, how much and of what. So if we do that comparison table and we say stoichiometry and recipe, they both start with something. Start with I'm just going to give you some of the stuff. Reactants. This is not rocket science. You knew that. Your recipe, or your reaction. Oh, stoichiometry is also always involving a chemical reaction. Something's going to change. Just like in your recipe, you start with ingredients. I don't know how to spell ingredients. There might just be one E. And you end with, in a chemical reaction, we get real fancy on these words. It's not real fancy. And recipe, you make your food, your finished product, your finished food. And there's usually some change involved in both of these. There's cooking or baking or heating or mixing together or some sort of acidic reaction or whatever. Your ingredients are not your finished product. There's like some cooking involved usually in cooking. Similarly, your reactants are not your finished product. There's some reaction involved. We could even describe, this is not on your printed page, but there's change in both of these. In your stoichiometry, there's some sort of reaction, and that's real generic, but you've learned 5 types of reactions, so there's some sort of reaction involved in stoichiometry. And in recipe, there's some sort of, cooking or baking. Which, from quarter 1, cooking or baking is also a reaction. There's some like salads where you are mixing things together, but like typically there's some sort of, like cooking or baking process involved in whatever you're making. We're gonna measure in, here's our units. You didn't think they were gone yet, they're not. Recipes, you're gonna measure in cups, tablespoons, teaspoons. If you're British, you're measuring in grams. If you're in a Great British Baking Show, they're always measuring in grams of flour, right? Like whatever it is that you're measuring in. And in stoichiometry and your chemistry stuff, your favorite unit of measurement by now, even though you learned it Monday of last week, you've written it so many times you're sick of it. Moles. Anytime we're thinking about a reaction or how much stuff, almost always in moles. Either moles or you'll see a second unit a lot in here too. The unit of grams. We use grams when we put things on a scale. Like a scale, like measuring. Amount. We as humans can measure grams. Moles we use anytime we're thinking about a reaction. Kind of like we saw on Friday, that mole ratio has to do with, whatever you're starting with, reacting to form something new. So anytime you're looking at a reaction, like we know from last week, the molar mass, the grams of something, has to do with what it's made of, and therefore is unique to that substance. Whereas moles let you think about reactions. They let you count particles in this really big number. So moles help you think about when things are reacting, how much you're starting with and how much you're ending with in terms of like a reactable quantity, a count number, instead of 1 atom, 2 atom, Now we've got moles of things, which are more equivalent to essentially cups, right? Like something that you can actually see. Just like you're not counting particles of flour, because that would be completely excessive. You're measuring that in a bigger unit. Same with moles. Instead of counting individual atoms, we're going to count those in moles. And our issue is that the mole of something depends on what it is. So when you put it on a scale, you want to know how many grams of that thing you're looking at from a scale perspective, like a balance, the electronic scales in lab. How much in a measurable, you can't put moles in a cup, without knowing how many cups you're looking for. Like, you still have to do that conversion. Okay, I'm gonna assume that makes some sense for you, although bring your questions if you have them, as always. Great. So this is kind of your setup stuff on stoichiometry. Usually when we do this in class, I hand you a puzzle. I give you a challenge and a puzzle and like a solid block of time in small groups, because I want you to think about it. Like, this is all fine and good and theoretical, right? In terms of, like, you don't know how it works yet in terms of like actual examples. So if you so desire, if you have the packet, this is in your packet. If you do not have the packet, here are the puzzle pieces. You can put these on puzzle pieces of your own. I'm not going to read them all. You can pause your screen. When I was thinking about this, I was like, this would be the Dora the Explorer version. Like, cut your puzzle pieces into individual pieces. There's 10 pieces on this page if you have this printed at home. I'll link it on the website also. And you're going to cut them out so that each puzzle piece is a ratio, and you're going to use a certain amount of these to build. I didn't actually give you the challenge question, did I? So the challenge question is the last question on this page from Friday. So Friday we did all the small ratio stuff, and then we got to that last question, and I was like, I mean, if you're feeling real ambitious, go for it, but otherwise leave that for Monday. So that's your challenge question that you're looking at. They give you a starting amount in grams, and they ask how many grams of something else would be produced or formed or used or whatever. Okay, so here you are converting from grams of one compound into grams of a different compound. You will note that this is on your mole ratio page. This has something to do with mole ratios, and more importantly, with a reaction. Anytime something is changing into something else, that is a chemical reaction. Okay, and we did some of the, okay, so in all of these practice questions from Friday, we had moles of one thing turning into moles of something else, moles of one thing turning into moles of something else by way of this mole ratio. So the mole ratio is the conversion factor when you're going through a reaction and changing the substance, like when H2 turns into H2O, that is a reaction. And to figure out how much, you're going through this mole ratio thing. The new challenge is, based on this, we're still going from the original thing to the ending thing. By way of a reaction, there is a mole ratio in this. Right square in the center is your mole ratio. But there's more, because now you're starting with grams. You gotta turn those grams into moles, and then take your mole ratio moles, turn them back into grams to solve for grams of the thing you're trying to solve for. I just gave you the answer, by the way. If you are looking for the pause your video and try your puzzle, this is a real good time to pause your video and try your puzzle, because it appears that I'm just giving you answers. So yeah, so these are where you would cut out your puzzle pieces, and your challenge, the actual question that you're trying to solve, is that last question on this page. Okay, I'm gonna let you pause if you want to pause, and I'm just gonna give you the answer. This is a video, not a classroom, and I can't, you know, you do you. You're the master of your own video controls. Off we go. Okay, so stoichiometry. What we're typically looking at here, not always, but often, we're looking to measure. So measure, and like I say starting amount, even though that's confusing because sometimes the question will say if you produce blah blah blah, how much of this other blah 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 did you start with? So we're always, here's how we're gonna do this. There's always gonna be some sort of your start spot, even though you know that your start spot could be a product, just like your start spot could be a reactant. So it's just math. It doesn't really care which direction your reaction is going. Your starting thing is your number. So start with your number. Your number. And that is your starting compound. Usually you're going to be working with a starting compound. We will do examples, don't worry, in grams. Okay, so you're going to start with your number. Your number tells you you're starting there. And then these are your guideposts. You know that your units are your guideposts. So your grams are your units. You know you're going to be reacting something. A reaction is going to occur. So you need to be paying attention to what it is as well. There's now 3 things in your high activity paying attention to brain. There's the number, there's the what the compound was, and what the unit is. Those all matter. That's just your starting spot. We're just getting started. Okay. You might want to write this the long way across your paper. Just realized. Okay. Because off we go. You're gonna convert this giant conversion. Take your grams of the starting thing. And the grams are nice, we can put those on a scale, but we're going to take this through a reaction. We need moles. We need to convert those grams into moles, and we're still thinking about that starting compound. CPD is compound. Okay, so starting grams, whatever the compound is you're starting with in grams, you're going to convert that into how many moles you have, because you're going to take it through reaction, and we need to know kind of a count in order to get through a reaction. Grams are on the scale, moles are in the reaction. So here's your reaction step. We've got moles of whatever you're starting with, and we're going to react to find moles of whatever you're ending with. That's your reaction step. And you know from Friday, if we're comparing moles, we are using the mole ratio. In your final step, you're taking those moles of the ending compound, and we want to take it back to grams. We want to put that back on a scale to see if our reaction actually worked. We want grams of the ending thing. And whatever we have left on top is our answer. Our grams of the ending thing is what we're solving for. And again, that ending thing could be a reactant or a product. Ending thing is whatever your question says, how many or how much. That's what we mean by ending thing. Again, could be a reactant or a product. Oh boy, okay, so this is your full template. Mine got a little squished because I wrote the first one really big. You may notice that these get long. They do. These are 4-step. So in your mixed conversion stuff, we got up to 3-step. Now we're almost always going to be looking at 4. And it's the whatever your number is your start spot. That's the starting compound in grams. Here's your conversions. Grams of your starting thing, you're going to convert that into moles of your starting thing, because you're going to take that through a reaction step. Here's your mole ratio. Moles of what you start with, you're going to convert that into moles of what you end with. So you just reacted, you just figured out the reaction step, the cooking step. How much did you start with? How much did you make? If we stopped here, we would know the moles of what we ended with. So that's cool. That's actually pretty useful, the moles of the ending thing. But if we want to figure out the grams of what we ended with, we'll take it from moles of that ending thing to grams of the ending thing to get grams of the ending. You'll notice that both of these steps here are grams to moles and moles to grams. Kind of like everything we were doing last week. This is a molar mass. It's that molar mass in 1 mole. Same thing here. This is also a molar mass. Find the molar mass in grams of that compound. It's that many grams in 1 mole. Same thing here. Find the molar mass of that compound. It's that many grams in 1 mole. They have a flow, as confusing as they kind of look. They have a flow. Okay, that's kind of the intro. We will do examples next, obviously. But for now, enjoy.